Alright, we're going to begin to start making some measurements. And we've done a little bit of this, but I want to focus in on how we reference those measurements and how we reference points and how we generally take measurements. So I've got 4 batteries here in series, so I've got 6-volt source here. And I've got 3 light bulb holders, and I have found 3 of my light bulbs that are 2.5 volts. So let me talk about that for a minute. 2.5 volts is what they're rated at. A bulb, if you've ever had a flashlight with the old incandescents, as that batteries start dying, you notice the bulb gets dimmer. So bulbs will work within a range of voltage. So this bulb, for instance, doesn't have to have exactly 2.5 volts to cut on. It may cut on at 1, 1.5, and work up to even 3 or 4 volts before the filament burns out on it if we overload it with too much voltage. So there is an operating range there. So with this 6-volt source, we're going to, and I've got my batteries kind of taped so they'll stay in place. And I'm going to tape my switch, and I'm probably going to tape him too, just to make our life a little bit easier, because I kind of need this to be still, at least for my lab. It might even be easier for you as well. So I'm going to go ahead and put my 3 2.5 volt bulbs into their bases and make sure they're contacting. And again, if you need to know where to read that voltage, it's on the very top of the bulb near where the metal part joins the glass. You'll find this particular kit I'm using had some 3.8, some 2.5s, and it looks like maybe one 5-volt one. I'm not sure if the 5-volt one's actually a 2.5, and it just didn't get stamped well, or exactly what's happened here. But anyway, we only need 3, so I know these 3 are 2.5 volts each. So we're going to come off the positive side, and this is our negative, this is our positive. We typically, when we switch a circuit on and off, we switch the positive side. So this is positive. And I'm going to come out of my switch into my first bulb. Now, I'm going to put these bulbs in series, and that ultimately means 2.5 volts. I've got 7.5 volts on a 6-volt source, 7.5 volts worth of lights, lamps. But that's okay. Again, they'll cut on. So we're going to have to series these things where we go into this one, out of that one, into this one, out of that one, so you get the idea. But this is my first load point, so this is really a point where we start losing some voltage, and I'll explain that kind of as we do the lab. But once we get to the load, remember, we see a difference in the positive and negative of our voltage. And we're going to see that here, but because there's more than one load, we're going to have a new dynamic kind of happening here. So now, if you follow my positive, it's going through my switch, out of my switch, into the first bulb, out of the first bulb into the second, out of the second into the third, and of course, as always, we've got to come back to our source here. So the first thing I'm going to do before we make any measurements whatsoever is make absolutely sure this is working. So I'm going to flip my switch, and sure enough, we have 3 fairly well lit bulbs there, and they're all about the same brightness, which indicates that I've got the 2.5 volts, I should say, bulbs in each one. Now the first thing I'm going to do is we're going to measure source voltage. And our source, of course, is the beginning and our end of our battery cells. So this is the positive side of our battery cell, and this is the negative here. Now, I can follow these wires, and as I follow, I can go here, and I know I should have 6 volts. Now, I'm not going to have anything there because the switch is not closed, so this ends my path. And I can stay here and go to right here, and I'm still going to have 6 volts. And we'll let you work with some of these on your own later. But the first thing I want to do is show you something, and I'm going to let you just take a moment and think about this. Pause the video. I'm going to close the switch. So I've got 6 volts here, and I've got 3 bulbs, and those bulbs are in series. Do you think each bulb is seeing 6 volts, a portion of that 6 volts, or exactly what do you think is going on there? And we'll come back to that. So I'm going to count to 5 and give you a chance to pause the video, think this answer to yourself, and then we'll come back. 1, 2, 3, 4, 5. So I asked you how much voltage you think was across each bulb. So I'm talking about across this bulb, then across this bulb, and then across this bulb. Well, there's only one path for current, and we know that this load of 3 bulbs is taking all 6 volts, but what they're really doing is they're dividing it. And because of the fact that they are an even value or an even bulb, they're all dropping approximately 2 volts. Now that's 1.7, 1.9, and if we can get across this guy, had him for a minute, up 1.8, had it there for a second. See if I can go out here. It seems to be this one that's giving me the problem. Let's get it out here to the lead, 1.8. So you may ask, if we have 6, why we're each less than 2, and that's simply because now that we're under load, our source is no longer 6 volts, it's 5.6. It's fallen a little bit because we've got such a tremendous load on our batteries that they are weakened somewhat. And if I open that switch, you'll see it goes back up. So just like when you're cranking your car, if you've ever been in your car and you've got your lights on your dash or your headlights on outside, and as you crank on that and that load is being drawn, that battery, those lights dim some. Kind of the same scenario here. So we've got a pretty close to 6 volts here, 5.9 now, but when we turn on the bulbs it goes down to about 5.7. So each of those bulbs is drawing approximately, or not drawing, but using approximately 2 volts. So we know we've got a 6 volt source, so if we're using 2 volts here, 2 volts here, and 2 volts here, that adds up to our 6 volt source. Now, here's another critical thinking question, and you can try it by taking it out. What happens if I take one bulb out and just run 2 bulbs? What do you think would happen? Still going to be applying 6 volts, and yes, we would have a 5 volt load, but what do you think would happen there? And that's a question you can try and see for yourself. And these bulbs should be robust up enough to handle a voltage a little higher than what they're supposed to. I just wouldn't recommend for leaving it on for days on end, simply because 1, it's going to kill your batteries, and 2, it could be detrimental to your bulbs. But I don't think it would be with just 2 bulbs in there create any problem. Now, we know that we're measuring there. Oftentimes, and let's call this, let's see, you're left to right. This would be bulb 1, bulb 2, and bulb 3. And so this is the positive side of, actually I've kind of got a reference more to me. So we'll call this, let's rewind that. We'll call this bulb 1, bulb 2, and bulb 3. I know that's backwards for left to right, but anyway, be this way. Bulb 1, bulb 2, bulb 3. Be right to left for you. So I'm going to reference voltages to ground. So my first question to you is, once I close this switch, how many volts relative to ground? Now notice I'm not measuring across each bulb. I'm leaving this probe on ground, and I'm asking you, what voltage will I read at this point? Then I'm going to ask you what voltage I would read at this point, and then I'm going to ask you what voltage I would read at this point. So voltage is kind of like payday. Everybody's got their hand out. So I'm going to close the switch, and we're going to read here, and what you're going to find is we're reading almost full voltage. And that's because that voltage is here, but we haven't read the value it drops. So if I start here, I've got close to 6 volts. It's getting a little lower. But here I'm going to have closer to 4 volts. If I can get on the terminal. And this is the same point, so it's still going to be 4 volts, but here it's going to be closer to 2 volts. And this is the same point, it'll be closer to 2. And this is the same point as where I've got my negative lead, so it's going to be 0 because there's no potential difference between the same points. So that creates kind of an interesting dynamic that we need to always be sure. So the terms we typically use are if I measure across bulb 1, what voltage did I read? Or if I measure across bulb 2, what voltage did I read? And if I read across bulb 3, what voltage did I read? Now if I measure from ground to the black terminal of bulb 1, then that changes everything in terms of the voltage I would get. I'd get 2 volts here, but if I read across this guy, if I'm reading across bulb 1, I'm going to have 2 volts. But if I'm reading the voltage between our ground point and here, I'm going to read 6 volts approximately minus the 2 volts that this guy dropped, which leaves me 4 volts. And if I say relative to ground in here, I'm going to measure the 6 volts minus the 2 that this guy dropped and minus the 2 that this guy dropped, and that's going to leave me about 2 volts. And if I read at this point, I'm really reading the exact same point. There is no potential difference. So that creates some things we need to understand and always consider with a series circuit. In a series circuit, the sum of the voltage drops is always going to equal source. So if I've got 3 bulbs here and they're pretty much the same, they're going to draw 1/3 of this source. If I've got 2, they should draw approximately half of this source. And if I've got 1, and do not run a 3.8 volt bulb on 6 volts, that will likely burn the filament. Running 2 of them shouldn't hurt it at all. They'll be a little bright, but they should be fine. The load or combination of loads in series, and remember that, in series, are going to, the sum of those drops are going to equal our source. Now the other thing that you need to know about a series circuit is the current through this circuit is the same at any point within that circuit. So I've got current flow coming out of my positive through this switch when it's closed, through this bulb, through that bulb, through that bulb, and back here. And theoretically, not counting the very, very minimal loss we have due to wires, which is pretty much negligible, current is the same at any point in this circuit. And I'm going to measure current here. So I'm going to take my meter and I'm going to go to milliamps, and we're going to start in the milliamp range, and I don't think this will be over a milliamp. Well, actually, let's start with the amps. So we're on the milliamp and amp scale, and we need to make sure we're on DC, and this meter defaults to, let me look, AC. So I have to press the yellow button to get DC. Now, in order to measure current, I have to have my meter replacing one of the wires in my circuit. So I've got a wire here, a wire here, a wire here, a wire here, and a wire here. I could choose any one of those wires and replace it with my meter. So let's just start here. It's closest to my meter. So obviously I've broken my circuit. We have no current flow. I'm going to have to close my switch. Now I have to move my lead, and I'm wanting to start with the amps because I always start high and work my way lower. Now this lead was going from here to here. In order for current to flow through my meter, I've got to use my meter in place of that wire. And if you look, we're measuring 0.26 amps, which is 260 milliamps. So I would be safe to go down to the milliamp scale, and we'll go to that in a minute. Now it's blinking a little bit because I'm just getting a bad connection. If I hold it really tight, I don't. And the reason it's negative is this is my more positive side, this is my more negative, and you see it's positive current. Now just in case you can't see that, let me turn the meter a little more towards you. So there we go. So we're going to move over to the milliamp scale now that we know we're not going to blow the fuse in the meter. And we're going to repeat that. And look at there, 260. And if you look real closely, I'll slide it a little closer to the camera. If you look in the picture, you'll see milli in the scale there. So we are getting 260 milliamps of that current through this circuit. Now I'm going to open my switch back again, and I'm going to show you current is the same at any point. So it doesn't matter where I break this circuit, I'm always going to measure 260 milliamps or something thereabouts. So the switch is open right now, so normally the switch joins this to this. I can let my meter join that to that, and there we go, 260 milliamps, so exactly the same. I could pick this wire here. I'll have to close my switch to pick it, but I'll pick that wire there. And again, I took the wire out that went here to here. It has to be joined back by my meter. And got to get down in there and not get a wiggly connection. There we go, 260 milliamps. So current is the same in a series circuit at any point. The sum of the drops by the load or loads, and if there's only one load, it's going to be dropping the entire source voltage. If there's two loads, each one will drop some amount, and if they're equal, it should pretty well divide it. But if they're not equal, it won't necessarily divide it in half. And what I mean by that is these bulbs are all have an equal resistance. But if this resistance was way higher than that one, we might have a different drop across this guy than as we do this guy. So let's kind of see that. Let me find something I think will work. Let's try a motor. And hopefully there'll be enough here to do what we want to do here. So I'm going to add in my motor. And I can guarantee this motor is going to have a different drop. So sure enough, in fact, what's happening is my motor is drawing so much of that load, it's not even allowing my lamps to come on. So most of my voltage is going to be dropped across here until I short it out, because I forgot I'm on milliamps rather than volts. So let's go back to volts and let's do what we were trying to do there. So I'm going to go across here, and if you look, sure enough, almost all my voltage is across this motor. So what happens is this guy's using up all the voltage and not allowing these guys to take much of it at all. So let's try an LED. That motor was just a little too much of a, let's try a beeper. That shouldn't require near the current and all that this motor did, but should still allow our bulbs to come on. And we'll just have to put up with the noise, and I'll have to talk over it because it's going to beep, I'm sure. Oh, it's doing the same thing, not allowing my bulbs to come on. So yep, let's try the LED. Should have went with my gut, but I wanted to do something a little different. So bear with me here while I grab out an LED here. And an LED should be okay because we're dividing this voltage. We certainly wouldn't want to put 6 volts across an LED, but I'm going to go ahead and close the switch. I'm just going to barely touch it and make sure. I probably got my polarity wrong on my LED. Yep, I did. This is my more negative side. Let's barely hit it. Let's make sure. Whoa, that's too bright. So I'm overdriving my LED. So that's not a good choice either. Don't want to blow up our LED. Let's see if we can find something that's in between there. Might not be able to. We'll try our unknown resistor. Let's see if that works. We won't be able to see anything physically, but yeah, we've got our bulbs on now. So you can see our bulbs are dimmer, so sorry about the rabbit trail there. But we know one thing, current is the same at any point, I could repeat that, and voltage drops are going to equal 6 volts. So I'm going to measure the voltage drop of bulb 1, or somewhere around 6 volts, simply because, so that's about a volt, 0.9 volts, so that's close to a volt. 1 volt, close to a volt. So this should be 4, or very close, 3.7. So the sum of the drops is still equal to approximately 6 volts. Again, we're weakening our batteries a little bit by putting them under some pretty good loads. But our current is the same no matter what. Now our current changed when we changed this. So we can measure that current. We'll go back and we'll see it's no longer that 260 milliamps, because as we change the load, we also changed the current. So let's go back and look at that. So I'll just go across my switch here and we'll see the current draw, hopefully. There we go. It is about 200 milliamps, or about 0.2 amps. So we'll go back to the millis. So our current did change by a pretty good factor. In fact, about 185 milliamps when we got down to a more clear scale. So that's series in a nutshell, and the main takeaways, and you can play with this. Again, just be careful if you're using the LEDs and bulbs not to apply 6 volts to only a single 2.5 volt bulb. 2 of them shouldn't be a problem. In fact, we'll look at that real quick. I won't make any measurements, but I will show you that. I'm just going to close the switch and hook those 2 and see no problems there. They're bright, but they're not going to burn up the filament. But if you were to do that to 1, you're probably going to take out your bulb and render that part of the kit useless. So, the takeaways. Voltage drops across the load in a series circuits are always going to total our source voltage. If there's only one load, it's going to take all 6 volts. If there's more than one load, it's going to divide equally. If the resistances of all the loads are the same, it's going to divide proportionally to the resistance if those resistances are different. But current, no matter what, is going to be the same at any point. Now that current's going to vary based on our source voltage, based on the resistance of our loads, but within the same circuit, current is going to be the same at any point of that circuit. So this should be challenging your mind a little bit and start getting you thinking about things and understanding it a little more. And do remember also, when we use the terminology measure across bulb 1, measure across bulb 2, measure across resistor 1, we're talking about across the component itself. If we say measure from ground here to one side or the other of a bulb or load, then we're talking about always keeping one lead on ground and putting the other to the other point there. So that's the difference in how we make measurements.